Welcome back. This is our Algebra 2 Exponential Functions lesson number 9, Graphs of Logarithms homework review. We'll begin with the question, the domain of y equals log base 3 of x plus 5 in the real numbers is, well, let's talk about what a log function is fundamentally. It is really the inverse of an exponential function. So a log function is the inverse of an exponential function. To find the coordinates of a log function, a logarithmic function, we can find the coordinates of the matching exponential function and switch the x and y values. Therefore, the domain of the exponential function of the form y equals b dx will be the range of the logarithmic function of y equals log base b of x. And the range of the exponential function in the form y equals b dx will be domain of the logarithm function y equals b log base b of x. So domain of any log function in the form y equals log base b of x is x is greater than 0. And its range will be all real numbers. So the idea now is that the inside part of the log base b of x, the inside part x you're plugging into, has to be numbers greater than 0. So how do we use that for our question number 1? Well, so we have log base 3 of x. So that means, so log base 3 x plus 5. So that would mean this part here that goes inside has to be greater than 0. So we solve this inequality by subtracting 5 from both sides. So our domain will be all values of x such that x is greater than negative 5, and that means we'll have choice number 2. Okay? You say, well, Mr. Gall, did you say it was like x is greater than 0? That's true if it was log base 3 of x. Because of its x plus 5 inside, we use whatever inside the log and set that to be greater than 0. Okay? Question 2. Which of the following equation describes the graph below? Well, there's particular coordinates here, and we see in this case, our two coordinates for this function are going to be, it looks like 1, 0, and then the other coordinate is going to be 4, 1. So in this case, one way to look at this was like, okay, well, I can try to find the log function that matches with this. But in this case, try to find the base here. Well, let's see. Well, we definitely know in this case that we would have, one way to look at it is to be y is equal to log base b of x. So we plug in 1 and 0, okay? Well, that makes sense. 0 is equal to log base b of 1, because b to the 0 is equal to 1. That's fine. Okay, any number to 0 power is equal to 1, except for 0, which the b cannot be. Well, let's plug in the other one, though. Okay? We have 1 equals log base b of 4. Well, if I rewrite this exponential function, b to the first is equal to 4. So we see in this case our b value must be 4. So we're looking at the equation y is equal to log base 4 of x. And that would be choice 4. So the technique is to plug them into the function and try to solve for b. Okay? Now 1, 0 works out for almost all of them, I think, but 4, 1 only works out for log base 4 of x. So we'll need to be able to convert from log to exponential and exponential to log. A very important skill we talked about in previous lessons. So again, if you have not watched those other videos of the lessons with logarithms, please make sure to review those as well too. Question number 3. Which of the following represents the y-intercept of the function y equals log base 2 of 32 minus x, close parenthesis, minus 1? Now the y-intercept really is going to be the value of y when x equals 0. So when x equals 0, we're looking for 0, y. That means we'll plug the x value with 0 and then try to solve for y here. So that means we're going to do y is equal to log base 2 of 32 minus 0 minus 1. Again, the y-intercept is not always the b value for a linear function. It is going to be the y value when x equals 0. So that's why I'm plugging in 0 for x. So y is equal to log base 2 of 32, then minus 1. Now we need to evaluate this here. We evaluated before. One technique is to set the log base 2 of 32 equal to n. We're not sure what it is, but we'll set that equal to n. And then we write this as an exponential function, exponential equation actually. So we have 2 to the nth power equals 32. Now 32 can be written as 2 to the 5th. So 2 to the n is 2 to the 5th power, which means n equals 5. Now that means that log base 32 is also equal to 5. So y is equal to 5 minus 1, because don't forget that minus 1, we get our y-intercept equal to 4, which is choice 4. Again, very important to remember what y-intercept means. It is the value of y when x equals 0. And when we plug in the 0 for x, we get log base 2 of 32. We have to evaluate. And we do that by setting equal to some variable, rewriting that log equation into an exponential equation, and then solving for n. Okay. Question number 4. Which of the following values of x is not in domain of log base 5, 10 minus 2x? So f of x equals log base 5 of 10 minus 2x. Non-domain, and we said before that our domain, this inside part, 10 minus 2x, has to be greater than 0. Whatever's inside the parenthesis has to be greater than 0. So we have to solve this inequality. Subtracting 10 both sides. We get negative 2x is greater than negative 10. Divide both sides by negative 2. X has to be, now, on the right side we get positive 5, but we remember whenever we divide by a negative number, inequalities, we must change direction of the inequality. So instead of being greater than, x must be less than. So we're looking for a value of x where it must be less than 5, all right? Or that's part of domain. But now we're looking for, since it's not the domain, we're looking for which one of these choices is not less than 5. And that would be choice number 3, because 5 cannot be less than 5. Which of the following is true about the function y equals log base 4 of x plus 16, close parenthesis, minus 1? Well, we'll see in this case y-intercepts, okay? The idea of a y-intercept is going to be the value of x, so the value of y when x equals 0. Sorry, y-intercept is value of x when y equals 0. Oh, sorry, that's x-intercept, sorry. The y-intercept is the value of y when x equals 0. We talked about before. The x-intercept is the value of x when y equals 0. And so let's take a look here, all right? So let's begin with our y-intercept, 0, comma y. And we that y is equal to log base 4 of 0 plus 16 minus 1. And so here we have, well, we have log base 4 of 16 minus 1. We'll evaluate this part here. And so we are going to get, we'll call that n, so log base 4 of 16 is equal to n. Rewriting this as an exponential equation, for the n equals 16, for the n is equal to 4 squared, n equals 2. That must mean that y is equal to 2 minus 1, or 1. This means it cannot be choice 1, and cannot be choice 5. Well, now we take a look at this and take a look at what the x-intercept. So let's take a look at x-intercept. Again, we're looking for the value of x when y equals 0. So now, again, the value of x when y equals 0 for x-intercept. So 0 is equal to log base 4 of x plus 16 minus 1. And so we solve for this, we're going to add 1 to both sides. Log base 4 of x plus 16 is equal to 1. Again, we'll rewrite this this log equation into an exponential equation. So that becomes 4 to the first is equal to x plus 16. Well, to solve for x, we subtract 16 on both sides, giving us a value of x equal to 4 minus 16 is negative 12. So our x-intercept is going to be negative 12. That means not choice 3, but choice 2. So our x-intercept is going to be negative 12, or y-intercept of positive 1. Okay? Ladies and gentlemen, this is going to be the end of our part 1 of our Algebra 2 exponential functions, lesson number 9, graphs of logarithms homework review. I hope this was helpful. I hope that you understood the steps involved. We took it step by step to try to find, in this case, x-intercepts, y-intercepts of log functions. We used some of our skills of rewriting a log function, into log equation into exponential equation, and solving from there. And also understanding in this case that because it works out really well because a log function is the inverse of an exponential function. So we're able to figure out what domains should be as well. If you found this video helpful, please give it a like. And if you have not done so already, please subscribe to the channel and turn notifications to be alerted when new videos are added to the channel. I look forward to seeing you guys in the next video. And again, just ask questions in the comment section below if you have them, or also take a look at prior videos on some of the other things we talked about when it comes to logs. All right, thanks so much for watching, ladies and gentlemen. I'll see you in the next video. Take care and be safe.